going to have a look today at greenhouse gases and the greenhouse effect. First of all, we're just going to think about what happens in a real greenhouse, because that will help us to understand why it's called the greenhouse effect. So there's the sun, here's the ground, and here's a greenhouse. So a greenhouse is made mainly of glass. So what happens is light rays from the sun can pass through the glass of the greenhouse, and they've got a short wavelength at the moment and a high frequency. When they hit the ground, they get reflected back at a slightly longer wavelength or lower frequency light. Now that light is unable to penetrate the glass, to get through the glass. So what starts to happen is those reflected rays can't get out of the glass, and the greenhouse itself starts to get hotter. So light from the sun hits the ground, so it can travel through the glass of the greenhouse, hits the ground. It is reflected back at a different wavelength, so some energy is lost when it hits the ground, and then it can't get out of the glass. So the greenhouse itself gets hot. So let's think about how that relates actually to what we call the greenhouse effect and greenhouse gases. So here's the surface of the Earth, and here's the sun. And here's the outer edges of the Earth's atmosphere. And remember, the Earth's atmosphere extends up to about 10 miles in height, and contains mainly oxygen and nitrogen, so mainly nitrogen in fact, but it contains small amounts of greenhouse gases, and particularly the greenhouse gases that we're interested in are carbon dioxide, very small amounts of a gas called methane, and also to some extent water vapor, so gaseous or gas water. So there are small amounts. Remember, there's only actually about 0.004%. There's going to be significantly less than 0.1%. So it's less than 0.1% methane in the atmosphere. And this is a process that has been happening for hundreds of thousands of years. But we'll see later that actually it's become an issue because we've started to release more of this and also more of this into the Earth's atmosphere. So as in our greenhouse, so I'm trying to draw a light wave with a short wavelength now. So short wavelength light from the sun travels through the Earth's atmosphere and hits the Earth's surface. So I'm going to say this is short wavelength light, or short wavelength radiation from the sun, particularly the visible part of the spectrum. So that's coming from the sun and it's going to hit the Earth's surface. Exactly like happens with our normal greenhouse, this gets reflected back with a longer wavelength. So reflected, so that radiation is reflected from the Earth's surface at a longer wavelength. Now, a lot of this will just go back into space. However, some of this radiation will be absorbed by our greenhouse gases, greenhouse gas molecules. I'm just using carbon dioxide as an example, but methane, CH4, and water vapor do this as well. And the radiation is absorbed by greenhouse gases. And that radiation is re-emitted as heat. Some of that gets emitted out into space, but some of it gets emitted back to the Earth's surface. So radiation emitted as heat. So this process is going to lead to an increase in the temperature of the Earth's surface. So let's have a think at a quick summarize of what we've done here. Short wavelength radiation from the sun hits the Earth's surface. When it hits the Earth's surface, it's reflected back. But the key thing is the wavelength has changed. Some of that radiation will just get emitted into space, but some of it will get absorbed by carbon dioxide, methane, or water vapor, so our greenhouse gases. And through various processes, that will then get re-emitted. So some of that gets re-emitted as heat back to the Earth's surface. So what is actually happening here is the radiation is being absorbed by the bonds in the carbon dioxide molecules and the methane molecules, and it causes those bonds to vibrate a little bit more. And when they vibrate, that causes energy, more vibration in atmospheric particles, and just leads to an increase in the temperature. So this is actually a process that is needed. Okay, without the greenhouse effect, I'll just call that, so this is the greenhouse effect, then the Earth would be significantly cooler than it is now. So we need a small amount of the greenhouse effect to keep the Earth's temperature at a temperature that's suitable for life. However, over the past 200 or so years, we have increased the amount of carbon dioxide in the atmosphere from a little bit over 0.03% getting towards 0.05% carbon dioxide. Now that is a significant increase. So that's a 60-70% increase in the amount of carbon dioxide in the atmosphere. So that is meaning more and more radiation is being absorbed. The reflected radiation is being absorbed and increasing the temperature of the Earth's atmosphere. Also, methane is about 200 times more potent as a greenhouse gas than carbon dioxide is. So carbon dioxide we have released into the Earth's atmosphere mainly by burning fossil fuels. And methane has been released through two purposes, two routes. So methane is as a result of intensive cattle farming, particularly. There are other sources of it, but intensive cattle farming releases a huge amount of methane, as does intensive rice farming and intensive soybean farming. But the large increase, particularly in cattle farming, has led to an increase in methane production. Cows basically release, as a result of their digestive process, huge amounts of methane. But also, it's starting to be released by the melting of something called the permafrost. So in places particularly like the North Siberian tundra, there is frost that has trapped lots of methane in it for hundreds of thousands of years. As the Earth's temperature is increasing, more and more of this permanent freezing is actually melting, so it's no longer permafrost, and that's releasing methane into the atmosphere. So it is of a concern to climate scientists. This has largely been accepted by the vast majority of climate scientists as something that's happening. But there are ways that we can reduce that. So anything that reduces the amount of carbon dioxide released by burning fossil fuels, so looking at alternative fuels that don't burn fossil fuels, that don't release carbon dioxide, will reduce this effect. And also potentially looking at how we farm in the future. Thank you very much.